Assalamu alaikum wa rahmatullahi wa barakatuh. Today we are going to talk about the fundamental theorem of calculus. Sometimes we call it the fundamental theorem of integral. The second part of this fundamental theorem, if I have to find the derivative of an integral. In brief, if I have a function that's continuous on interval and I want to find the derivative of an integral, all what we do, we cancel the derivative and the integral, which means the derivative usually cancel the integral because the integral is the antiderivative. So the derivative of antiderivative, they cancel each other, so we get the original function, but instead of t, we replace x, so it will be f of x. For example, here, the derivative of the integral from minus 2 to x, all what we do, we cancel the integral with the derivative, and we replace x here. In this case, we will get the same function, the original function, x squared plus 1, and we ignore the lower bound of integral. But in some cases, the boundaries are not numbers, or the boundaries are both functions. In this case, or one of them function and the other one is not function. This is, we call it the opposite of chain rule. All what we do, the integral will cancel the derivative, but we replace the function, the upper bound of the function, multiplied by the derivative of that function. And also, we replace the lower bound of the function multiplied by the derivative of that function. So, in brief, we can say f of up by the derivative of up minus f of down by the derivative of down. Let us take some examples. Look here, we have derivative of an integral from 1, which is a number, to a variable, which is 1 over x. In this case, the derivative will cancel the integral, but at the same time, we will replace 1 over x. Since it is a function, not only x, so we replace, then we multiply it by the derivative of 1 over x, that we know it is negative 1 over x squared. So in this case, the result will be, we replace 1 over x instead of t, then we multiply by negative 1 over x squared. We ignore the lower bound because it's only a number. We ignore the lower bound because it's only a number. Now, look at this example again. Also, I should do what? I cancel the derivative with the integral. Then I replace x squared instead of t, then multiplied by x, the derivative of x squared, and we ignore the lower bound. So we just replace x squared instead of t, then we multiply by the derivative of x squared, that we know it is 2x, so the answer will be cosine x squared multiplied by 2x. And let us take another example. If I have two functions in the boundaries, all we do, what we do, the derivative will cancel the integral, then I replace x squared first by the derivative of x squared, minus what? We replace 2x by the derivative of 2x. So all what I do, I replace, instead of t, I replace x squared by the derivative of x squared, then minus, I replace the down by the derivative of the down. So what I did only, we replace the up, instead of t, then by the derivative of up, minus, we replace down by the derivative of down. This is called the general form of the fundamental theorem of calculus. Let us take some example here. Here we have limits with integral. So we can use L'Hopital, but before using L'Hopital, we need to check if we can use L'Hopital or no. All what we do, we check, we test, we replace 3. When I replace 3 here, it will be up integral from 3 to 3. And we know integral from a number to itself, whatever the function, will give me what? Will give me 0. And in the denominator, when I replace 3, it will be 3 squared minus 9, and it is fact, we know it is also 0. So the answer is 0 over 0. So yes, we can use L'Hopital. To apply L'Hopital, we find the derivative of the numerator over the derivative of the denominator. So in this case, it will be limit, as it is, still there is limit, then the derivative of up by the derivative of down. What's the derivative of down? It's easy, it is 2x. But what's the derivative of up? And in this case, the derivative will apply fundamental theorem of calculus. The derivative will cancel the integral, and it will be only tan x. It will be only tan x. Then after that, I replace the limit, or I solve the limit as a normal limit when x goes to 3. Then when I replace, it will be tan 3 over 6. Tan 3 over 6. Then let's take another example. If I have a graph of function consists of semicircle and 2 line segments, and there is another function called g of x, which is the integral of the graphed function of x. And I want to find the derivative of g prime. The derivative of g prime, all what we do, we will cancel the integral and we will replace up, so it will be f of x. That means the derivative of g prime, it's f of x. So now it's easy. If I want to find g prime of -1, all what I do, I replace -1, so it will be f of -1, and f of -1, it is from the graph, f of -1 from the graph, it's very clear, this one, which is, it's 2. Then same, if I want to find g prime of 2, which is f of 2, and f of 2 in this case, here it is -1, and g prime of 1 will be the same, -1, g prime of 1, which will be f of 1, and f of 1, we know it is 0. Now if I want to find something else, so like the second derivative, in this case, if I want to find, for example, the second derivative, or the second derivative of g, so g double prime, so g double prime in this case, it is f prime, because we just continue driving, so it will be f prime of x. And if I want to find g double prime, for example, of g double prime of -1, in this case, we know g double prime of -1, there is a horizontal tangent there, g double prime of -1, here there is a horizontal tangent, so it will be 0. Thank you very much for watching.